All right, happy Tuesday. Welcome to Functions Vocabulary Day. And what we're going to do today is go through this graphic organizer right down here about some vocabulary words related to functions. And then you're going to have this assignment to do, which is domain, range, and functions. Okay? And you still have your progress check tomorrow. So, due to the length of this assignment, like I've done in the past, this assignment will be due on Thursday, the day after the progress check is complete. Okay, so make sure you watch obviously this video, which is the functions vocabulary, and then functions, domain, and range, which will give a little bit more definition and meaning to the domain and the range of a function. Okay, so don't forget your quiz tomorrow. All right, so let's go ahead and dive into this. You can pop this out and print it. You can write it in your notebooks. You can Cami it, whatever works for you. Okay, so as we start, the basic definition of a function is that it is a relation in which each first value is paired with one and only one second value. And so we've talked about that before when we first started with functions, that it's one input or first value to one and only one second value or output. And I would make sure I know that for tomorrow. Hint, hint. So if we take apart this definition of a function and we see here the word relation, a relation is nothing more than a set of ordered pairs. So over here, I'm going to create just a set of ordered pairs. And we're going to talk about these ordered pairs real quick and what they mean in terms of a function. So go ahead and do this with me. What's happening here? Okay, that's it, just an 8. I don't know where those marks are coming in from. All right, so when you look here at this set of ordered pairs that we have, this is simply what we would call a relation or a set of ordered pairs. Now, right down here, I want you to either write or type in the first additional definition, which is going to be domain. And the domain is the set of x values in a function. Or just simply put, all the x values or inputs. All right, so that's what your domain of the function is. It's the set of x values, or basically all the x values or inputs of the function. So that's what we have as the domain. Then the other thing we have is what we call the range. And the range is the set of y values, or all the y values or outputs. Okay, so these two words here, domain and range, will be with you for the rest of your math career. And you learned it here first in Math 1. All right, so if we look here at this relation here, my domain would be that set of all my x values. So 0, 4, 5, 6, and -1. That would be my domain. And my range would just be the set of all these y values. So that would be 2. And since 2 occurs more than once, you would just say it once. So 2, -4, 3, and that's a regular 8. All right? So the question over here says to decide whether the relation is a function, yes or no, why or why not. So, like we say here, the function is where each first value is paired with only one second value. So if you look here, the simple way to do this is look at your x values. Do any of your x values repeat? Meaning, do I have any more than 1 0, any more than 2 4s, or excuse me, 1 4? Do I have more than 1 5, more than 1 6, or more than 1 -1? The answer is no. So what we say here is decide whether the relation is a function, okay? And we would just circle, yes, it is. And the reason it is a function is because the x values never repeat, and there is only one input paired to one output. Okay? So the easy way to remember it is, do any of the x values repeat? If the x values do not repeat, then it is a function. Okay? So that's our first one over here. So now, if we look here, we have these two input-output tables. Okay? Now there again, an input-output table is a relation, because an input-output table is nothing more than a set of ordered pairs. Okay? So I have here 2, 3, 2, whoa, another advertisement. 2. And all right, so there's my x values. Now for my y values down here, I'm going to have 1, 2, stop doing that, 3, 4, and 5. Okay, so let's look at this first input-output table. Remember, my inputs are going to be x and my outputs are going to be y. So is this a function? Well, the question I'm going to ask myself, do the x values repeat? And if you notice here, you have a 2 here, and you have a 2 here. So my x values do repeat. So since my x values do repeat, this is not a function. So what I'm going to do, because I'm also going to look at this one, I'll just draw a little line right here, and I'm going to say not a function because the x values repeat. Okay? So this is not a function because the x values repeat themselves. So if we go over here to this other input-output table, and we'll just start here. Now again, remember this is ordered a set of ordered pairs as well, so it is a relation. All right, so let's look at this one now. I have 1, 0, -1, -2, and -3. So do any of my x values repeat? None of my x values repeat. So I'll just draw a little line from this one, and I'm going to type yes, because the x values do not repeat. All right. So you have an example of one that's not a function because the x values repeat, and then one where it is because the x values do not repeat. Okay? So the next thing we'll look at down here is what we call function mapping. And function mapping is nothing more than just another way to arrange your work and to help you visually see inputs and outputs. Okay? So if you remember here, your x values are your inputs and your y values are your outputs. So if I come over here and I'm going to put the text box, and I'm going to have 1, 2, and 3. All right, so those three numbers there are going to be my inputs, 1, 2, and 3. And then my outputs are going to be 0, 3, 4, and 5. Okay, so here's my set of inputs and my set of outputs. All right, so now I'm just going to take this drawing tool and I'm going to basically do what we call map each of these. So 1's going to map to 3, 2's going to map to 4, 2 is also going to map to 5, and then 3 is going to come up here and map to 0. All right, so the question then is, decide whether the relation is a function, yes or no, and then why or why not. So if you look here, the 1 is paired to the 1 value of y, which is 3. But notice my 2. My 2 actually maps to two y values, 4 and 5. So that does not meet the definition of a function because the first value is paired with 1 and only 1 second value. Down here, the first value of 2 is actually paired with 2 values. And then 3 is just paired with 1 value, 0. So what we would write here for why or why not is the number 2 is paired with 2 y values. Okay, and so if you were to make that as a table of values like you see up here, an input-output table, 2 would be occurring 2 times. Or if you were to write it as a set of ordered pairs, you would have 2 occurring twice over here in your x values. All right, so that's our first part about functions. Okay, now this next thing we're going to get into is what we call the vertical line test for functions. And what we say here for this vertical line test is a vertical line crosses only one point on the graph. Okay, so what we need to remember is that when we graph a function, and this is part of why we did the input-output tables in graphing yesterday, is that each of these points, the x's are my inputs and the y's are my outputs. All right, so what I'm going to do here in quadrant number 1 is I'm going to draw a line, just like that. And in quadrant number 2, I'm going to draw a circle. And in quadrant number 3, I'm going to draw a parabola. And then in quadrant number 4, I'm going to draw something that looks like that. Now, here's what the vertical line test says. If it is a function, the vertical line is only going to cross one point on the graph. So that's referring to the graph of each of these, okay? So if we're determining if this here is a function, this is the graph that the vertical line can cross only one time. So remember here, x's are my inputs, y's are my outputs. So as I draw the vertical line through this function, if I draw a vertical line here, it only passes one time, which means there's one input for one output. If I draw a vertical line here, again, it passes one time, which means there's one input or one x value for one output or y value. If I draw a vertical line here, that means, again, there is one input for one output at that point on the graph. So what does this tell us? What it tells us is that no matter where I draw a vertical line on this function or this particular graph, that it is a function because it's only going to cross this graph of the line one time. Okay, so since that one is in quadrant number 1, what we're just going to do over here is put the Roman numeral 1 and say, yes, it is a function. Okay? So quadrant number 1 is a function. Now, if I look over here at quadrant number 2, and if I do the same thing and draw a vertical line, let's suppose I start right here. My vertical line crosses the circle at 2 points. It crosses here and it crosses here. So that means for this input of x, there are 2 y values that output. Same thing here. If I draw my vertical line, what that tells me is for the input here, again, there's 2 outputs. And what you're going to notice is that no matter where I draw a vertical line on this circle, it's always going to intersect at more than one point, meaning for each input, there's more than one output. So what does that mean? Well, it means you can graph a circle, but it also means that the graph of a circle is not a function. So for quadrant number 2, we're going to say not a function. And the reason it is not a function is because it does not pass the vertical line test. Okay? And number 1 is yes, because it does pass the vertical line test. All right. So let's look over here at quadrant number 3. Quadrant number 3 has our parabola. So same thing, if I were to draw vertical lines through this parabola, what I'm going to see, again, is that no matter where I draw that vertical line, it only crosses this graph one time. Okay? In spite of my messiness, a parabola is a function, and it's only going to cross one time. So that means for each input, there is one and only one output. Okay? So we'll come over here and same thing. We'll say for quadrant number 3, we'll say yes, it is a function because it passes the vertical line test. All right. So then let's go over here to quadrant number 4. Okay. So quadrant number 4, here's my graph. So if I draw a vertical line over here, it crosses in more than one place. If I draw a vertical line here, it crosses in more than one place. And if I draw a vertical line here, it crosses in more than one place. So that means, for example here, this input of, it looks like 7, there's going to be 2 outputs. And for this input of 5, there's going to be 2 outputs. So since it does not meet the definition of a function with 1 and only 1 second value, okay, and it does not pass our vertical line test, what we're going to say then is for quadrant 4, we're going to say not a function because it does not pass the vertical line test. Okay, and in the additional video that I've included, it goes over the vertical line test again, so you can see it again and hear it again if it's not clear from what we've talked about. For some people, they get vertical line test right away. Others, it's a little confusing until it sits in after a few times. But the thing to remember is the vertical line can only pass through this graph right here. So whatever the graph is, not your coordinate plane, but whatever graph you're testing, that is where it can only pass one time. Okay? So these are the function vocabulary notes. You're going to hear these terms used quite often: function, relation, domain, and range. And knowing the vertical line test is a strategy for telling if something is a function or not. So then you can go ahead and get started on the assignment here. And like I said, this will be due Thursday just due to the length of it. You're going to look at each of these and write the domain and the range of the sets of ordered pairs. Then for the next part, you're going to write the domain and the range for either the table or for each of the graphs that you see down here. And then for these, you're going to determine if each relation is a function or not. So for some of these, you're going to get to use the vertical line test. Others, you're going to have to look, is the x value repeating? So you get to use all three different strategies. All right. So as always, come and see me on Google Meet. If there's something that isn't clear, you can email me as well. Please make sure you take your progress check tomorrow. And this is due on Thursday. So have a great day, everybody. Thank you for listening, and I wish you all the best. Have a good day.